Good morning, this is my Miss Cash, and this recording is for Algebra 2. So if you are in my Algebra 1 class, go ahead and turn this off and watch the one for Algebra 1. This one is for my Algebra 2 class. Okay, Algebra 2 class, these are some notes that you need to have in your folders about multipliers for exponential growth or decay. You may already have these notes in your folders. If you took them on the board about 2 weeks ago, they were on the board. But several folks don't seem to have them in their notes. So if you do not have this in your notes, you want to go ahead and get it in your notes. So pause this now and copy these down before you move on. I will be checking to make sure you have these in your notes tomorrow, and there will be a reward for those who do. So again, pause it and take notes if you need to. However, for everybody, I want you to add this to your notes. If you want to add it to those notes on multipliers, if you already have them, you may. This is just an example of using that type of multiplier. We've done this kind of example before, but I want to make sure you guys get a good idea of how to do it. This one's talking about a culture of a bacteria. It grows by 1% a minute. It gives you an equation, but it's not quite a complete equation. It says y equals 200 times parentheses b to the power x. We are going to need to figure out what that b is here in a minute. First, though, A asks us what is the population at 515. Well, 515 is where it says it started. Our starting value is always evident when we use our equation. It is the A value, which is the very first value right here. So that is our A value. That is our initial value, or our zero term, if we're talking about a sequence. And so just by looking at the equation, we know our initial population to be 200. What multiplier should be substituted into the equation for B? So here is where we're going to have to use those notes from the previous slide. To get a multiplier when we have growth, we always start with 100% and we add the percentage growth. Now, sometimes I told you to add that and then change it to a decimal, but the formula I gave you on the page before just goes ahead and puts that in parentheses and divides by 100. If you do that in your calculator, it will turn it into the decimal for you. So remember that. Just add to 100 in parentheses, then divide by 100. That gives you 1.01 as your multiplier. So finally it asks me, what will be the population at 540? Well, we need to know how much later is 540, how many minutes have passed. So let's take 540 and see how many minutes have passed since 5:15. By the way, you can't subtract like this if you change hours because there's only 60 minutes in an hour. But regardless, 40 minus 15 is 25. So it's 25 minutes later that we want to know how many bacteria there are. So we're going to use our equation. Y equals 200, our starting value, times our multiplier, 1.01. Now you can put this in your calculator as the power x, and then scroll down to number 25 in the table if you use the y equals function, or you can simply put the number 25 here in the exponent to get your answer. And I'm going to take a second to find out what that answer is. You also, while I'm gone, please take a second and type that into your calculator. So when I type that into my calculator, I get 256.48, blah, 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 right? But if I'm looking for whole bacteria, I'm going to round to the nearest whole number as 256. bacteria. And that is my answer to that one. So that is an example problem for you. Just to do a very quick example on the next page. I did not prepare this one ahead, but decided you might want to see one more example. If you have something that decays or decreases, such as a car that depreciates over time, or the number of people are moving out of a town and so the population's going down. So let's take a car. Let's say its starting value is, let's buy an expensive car. Let's buy like an Escalade or something even more expensive. Let's say it's $40,000. But some of those expensive cars, their values go down really fast. So let's say it loses 12% per year. And I want to know what that car going to be worth by the time you get it paid off. Well, on a $40,000 car, I bet you took a 6-year loan. 6-year loan's a bad idea, by the way, because cars go down in value. But let's just try it out. Let's see, by the time you've paid that car off, how much is it going to be worth? So let's start by finding that multiplier. The multiplier is going to be B, of course. And we're going to do 100 minus 12 because we lose 12% of the value. Parentheses, then divided by 100 to get our multiplier. 100 minus 12, that would be 0.88. You can do that in your head or you can stick it in your calculator. So we know our multiplier. We need to go ahead and figure out 6 years from now. So let's write the equation. Y equals our initial value, 40,000, times our multiplier, 0.88, all to the power. If it's 6 years from now, we'd put 6, or if you want to put x there and put it in the y equals in your calculator, then you can scroll down to your 6. Give you just a minute to type that in your calculator and see what the answer is. All right, and when I type that in my calculator, I get that you have $18,576.16. So it's worth less than half of what you paid it 6 years later when you've gotten it paid off. Be careful when buying cars because it's not always a great deal to buy that expensive car because they do lose value. Just something to think about. All right, so I've given you 2 good examples to look at. You've got a worksheet with about 8 problems on it. I think that's very doable for today, so I expect you to get to work and be ready to show me not only your work tomorrow, but those notes that you took on this. Thanks and have a great day.